Greetings and salutations. Welcome back to another episode of the Tech Talks Daily podcast. And today we're going to geek out a little because I want to explore a fascinating and groundbreaking topic in the realm of artificial intelligence. I want to explore a unique aspect of it today. I want to talk about the concept of unlearning in AI. And I've got the CEO and co-founder of Pathway joining me today, and that is a pioneering startup based in France. And in a world where AI and machine learning are rapidly evolving, Pathway is a company that stands out with its revolutionary approach to AI unlearning. The technology allows AI models to selectively forget or revise outdated or incorrect information, similar to updating a single cell in an Excel sheet without reprocessing the entire document. And for me, this innovation holds immense potential for the evolution of AI and its applications in various industries. And my guest today, Zuzanna, she has a rich background in forecasting and complex systems. So she's going to guide us through the intricacies of AI unlearning and also explore how Pathway's technology enables real-time dynamic updates of AI models, the challenges in implementing this technology in complex systems like neural networks, and the real-world implications for businesses in sectors far and wide, from logistics, legal searching, financial trading, and so much more. So whether you are a tech enthusiast, an AI expert, or just someone curious about the future of machine learning, this episode promises to be a thought-provoking journey into the cutting edge of technology. But enough from me. Buckle up and hold on tight as I beam your ears all the way to Paris, where we're going to talk about all this and much more. So a massive warm welcome to the show. Can you tell everyone listening a little about who you are and what you do?
Absolutely. So I'm Zuzanna Stamirowska. I'm the CEO of Pathway.com. And Pathway is the fastest and the easiest event processing engine built for the AI era. And I lead this company. I founded it. I have a background in research. I'm the author of the state-of-the-art forecasting model for maritime trade. Spent years working on complex systems, everything that's large, not easy to comprehend. And you would like to make sense of it and predict it somehow. I'm a mom of two. I live in Paris, so calling in today from Paris. I guess that's it.
Awesome. I absolutely love that. And what I try and do on this podcast every single day is demystify some of those complex technologies we keep hearing about. And obviously artificial intelligence and machine learning is all anyone's talking about this year, and I suspect next year as well. But I recently come across the concept of unlearning. So can you elaborate on what unlearning means, especially in the context of AI and machine learning, and how this differs from traditional model updating and retraining?
Of course. So generally speaking, the purpose of unlearning is to make sure that when we delete some input from the training data set, it's being deleted along with all its footprint. So that, let's say if we were to draw a line between the bit of input, everything that results from it, all the ends of the line on the other side of the model, all the impact of it would be deleted. And now this is something that is possible when we're talking about linear systems, but it's not obvious. For AI that we talk about right now quite a lot in the media, like Gen AI, but really large language models, it's a bit more difficult. Technically, we would say it's hard. And we can get to it but maybe a bit later. So how it differs from retraining and kind of fine-tuning, etc. Well, the difference is that really if you are in the state of if you're just retraining a model, that means you change you're doing everything from scratch in a way. So you take maybe if I can give you kind of the context of how learning works. You usually have a training data set. It's a batch of data. You train the model on the training data set, and then you have the model at the end. So it's a batch operation. So it's based on a batch of data that you take at the beginning for the training. Now, if you want to change the inputs, you kind of do the procedure again. So it's periodically people, in fact, retrain their models. That means they change the training set, they delete elements of the data set, and they train the model again. So this is, let's say, the traditional kind of pretty static way of forgetting. It's pretty costly because it means that every time you have to actually retrain them all. So this, however, works for like traditional models and large language models, deep learning, but is pretty expensive and just not reactive. I mean, in any case, you are working on all the data. I mean, just by definition, because you took the batch at the beginning. So this is, let's say, how continuous unlearning differs. I think it's this really layer of being able to do it live, to react to new data input and delete it swiftly from the kind of training data set, but also like delete all the results that were impacted by that data point. And this is something that you can do when you're looking at kind of more linear models that can be somehow linearized or generalized in such a way. These are often the structures that you look at when we talk about like even clustering. We're looking at trees very often. There are like some of the models that are well known in more traditional machine learning are decision trees, random forests, etc. And here it's in fact difficult to do unlearning, but not impossible. And if I can give you maybe an example of how it looks in such a linear model, we could, and why it's difficult already. We could look at the example of let's say computing a maximum. So we just want to compute a maximum of numbers. Let's say we have 1, 2, 3. And we're looking at the scenario where our data is not static, so we may be getting new data points arriving in a stream. Okay? Yeah. So we're not in this static kind of batch world. Right now we're in a more reactive kind of real-time world. So we have 1, 2, 3. We compute the maximum. It's easy. It's 3, right? So this is fine. Now, it's not too tough to do updates to the model. Let's say we got 4 or we got 5. I mean, we just kind of compare and we know it's 5. But let's say we delete, all of a sudden we're asked to delete one of the numbers. That's getting tougher because in fact we have to go back, and this deletion may or may not impact our maximum. And the way to implement it, the way that, a good programmer should go about this, would be to design, in fact, a structure that looks like a tree. And in this structure, the deletion would be, in fact, equivalent to just erasing a branch from the tree. And then it's easy because you just look at the branch, you erase the branch. But that kind of programmer that you try to hire, for example, would be very unhappy if she had to do it every day. This updating of past results is in building that structures every time there is something that actually is changing, that you get that you get updates or deletions to your model is very painful. And this is where certain levels of automation and infrastructure layers like Pathway come in to make it easy. And then we just talked about maximum, which is a very kind of simple case, right? Relatively simple case. But then there are all the other models that pretty much generalize as just enormous numbers, so like multiple tree structures, and this gets way more complex. And sometimes you may even want to combine a number of different models, right? So of course, like not every model will be can be easily translated into this, but I mean many can to some extent. So you can make them way more reactive. And here, I mean, I listed some of them, and like we have them running, and they are like very useful. So supervised learning, like clustering, works great. Random forest, etc. And then, I mean, we can talk about LLMs maybe when we get to Gen AI, because this is where things get actually very tricky from my both scientific point of view and practical implications.
And just to bring to life what we're talking about here, what would you say are the immediate and long-term implications of this capability for enterprise applications of AI? Is there any particular industries like manufacturing, financial services and logistics that are more impacted than others? How does it all work in the real world and solving those real-world problems?
The keyword here is operational analytics.
Yeah.
So when we talk about operational analytics, we're not talking about just a report that somebody reads at the end of the month or at the end of the year. We're looking at results of analytics that then feeds other systems or feeds decisions that are made rather quickly. So let's say we're looking at a couple of minutes to milliseconds, in a trading system that would be a milliseconds, and you get a lot of bonuses, let's say, if you shave off milliseconds there. And then for logistics, and it can be like big minutes, etc. But this is sometimes this impacts a number of like orchestration of flows at the operational things. So anyway, we are in the operational analytics space. This is probably like Gartner says is like 2/3 of streaming use cases in general, because this is where you care about reasonable latency that allows you to actually do something about the result that comes from the system. And then when we look at logistics, yes, this is a case where you actually have a lot of event streams and pretty complex data. And the unlearning, oddly enough, comes at very kind of down to earth places. So in logistics, what you get is that you get location data about your favorite assets. I don't know, your Christmas parcel, let's say. So you're about to get your Christmas gift. And for kids, we could say that this could also be the Santa sleigh that's tracked. And you want to understand what's happening. You want to get the status to kind of know if you should stay awake in the evening, to catch the Santa going down your chimney. And this is what you're doing. Well, in big logistics cases, there are actually people who are waiting, for trucks to arrive in distribution centers and stuff. So what you want to get is that you get data that comes from real world, often IoT data, which is in fact pretty noisy and not clean, which has a very specific, also like special way of arriving late. So it may be possible that you will get information about an event that happened or like a location measurement that would arrive in inverted order. So if you were to project it on a map, you will get a strange jump, unlogical jump kind of, because all of a sudden your Santa went to, if he was in the UK, went back to Sweden and then went back to the UK. And that's just because of the order in which data points were arriving. It's not that Santa really did that. It's just the order of the data points. And this has to be fixed. And then there are also, like GPS jammers. I mean, noise. Generally speaking, we talk about noise. And then there's data that's generated by people, etc. And you want to make sense of it because you want to know when the Santa is arriving. And here you actually unlearn because you have these errors. You need to detect the error. And if you look at logistics, it's like a bit like a state automaton, just that this state automaton never works. If you were to just design a state automaton and assume your logistics processes would fit, it's a bad idea. If anybody listening tries to do it, please don't. It's not going to work. Usually you want to actually mine the process from the data and then see divergences. Kind of you want to see how it changes, and it's way better. And this is what you use, kind of this continuous learning in a way with unlearning, because you may want to iteratively clean your data to know that, okay, I just got a new data point, which was in fact in the past, which means that indeed my Santa is in the UK. Everything is fine. There's no delay. And you keep on forgetting some stuff or correcting your understanding as new data points arrive. And data points arrive. They may concern the past, right? So you actually keep on doing updates to your past decisions in a way. And you correct the vision, let's say the functioning of the model at the given moment. And so that's logistics. So let's say this is data fusion. The technical term here really is data fusion. So that would be used by logistics, but same thing is used by Formula One racing teams in analytics. You have streams of data arriving like this that you have to understand, clean, put together. You have also in manufacturing, because I believe you mentioned this in manufacturing, it's still data coming from physical systems. So this is where it comes useful. Financial markets are, I think, even more interesting. In financial markets, what you can get, there was a case when there was a tweet, like a fake news, on Twitter that spread, and there are automatic trading systems that make decisions, and they actually take data, kind of aspire data from social media to make some decisions about, buy, sell, etc. So imagine you have a fake news that's spreading. Your trading system started acting upon the fake news. So that was actually an incorrect action, right? That's very harmful for the market and probably for the company that's trading. And you may have a system that actually detects the fact, okay, that news was fake. You can imagine it's 100% automatic. Then you want to correct the actions. So you need to be able to make sure like there's synchronization across the systems. And so this is where we see the impact of, the ability to unlearn, to see that something was, some action was erroneous, and to make sure that other systems are synchronized with the new corrected version of the truth. Does it make sense?
Yeah, it does. And we're going to further complicate things now, because you did mention generative AI a moment ago. And for many people listening, generative AI is simple. I ask it a question, it gives me an answer. But of course, if you look under the hood, things are much, much more complex, especially when you're talking about workflows. So how does the ability of AI to unlearn intersect with generative models? Are these synergies or challenges, or are there any synergies or challenges that we should be aware of?
Yeah, absolutely. So there are both synergies and challenges, and kind of maybe the ways or designs that we can put in place to make it work. And of course, there are some like ethical challenges around this. I mean, in Europe, we have the right to be forgotten, for example. And then if we rely more and more on large language models, so generative AI, let's say, this forgetting is proving harder to put in place than expected. So there are also regulatory questions. So generally speaking, and large language models, because this is what I'll be talking about, it is hard to forget. It is hard because, as opposed to the systems I was talking about at the beginning, we are not in a linear context. So we actually have multiple dimensions, and if you wanted to kind of imagine this a bit more, you may imagine that you're like standing on a flat plane. Flat plane is your linear system, linear situation. You stand on a flat plane, and you're going 10 steps forward, and you ended at the location you put a cross, let's say, on the ground. Now going back to the starting position, you make 1 step left, 10 steps forward, 1 step right, and you end up at the same position. So we can easily, in fact, map and predict where the different paths will lead you, right? In the linear space. So this is fine. But when we are in the nonlinear, like high dimensional space, imagine you're standing on a curvy, like on a hill, let's say. So when in fact you do this 1 step left, you're shifted way more than you were when you were standing on a flat plane. So you will end up in a different location than you would have on a flat plane. This means that it's very hard to map a piece of input to a piece of output. Like by definition, like you kind of can't do it. So it's extremely difficult to forget things because you don't know how they contributed to whatever the LLM learned. And we don't know. Honestly, the truth is that even the researchers who made them don't know. They don't know how, like, if even LLMs are building concepts, et cetera, we just don't know. It's about as like asking you if when you were a kid and you were learning to play piano, I mean, to what extent a given piece of music contributed to the way you're, spreading your fingers or something. I mean, you wouldn't know. I mean, probably you would feel like if somebody asked you to unlearn one of the basic songs that you learned to play, I mean, probably a musician wouldn't know how to go about this. Yeah. And so this is where we are. The challenge is that, really speaking, LLMs rigorously cannot learn. People try to do something about this approximately. But there are ways to go about this if you treat the LLM a bit like the ability, the skill of playing piano, but you keep the knowledge you keep the knowledge, so all the musical pieces in the context. And this is something that we call RAG. So it's retrieval augmented generation. And here, what you can do is that if you're able to process a lot of data quickly, you can delete and upsert, right? You can delete and change the data, the context that's fed into the LLM quickly. So you can, in fact, have even the models we were talking about, the linear models that we were talking at the beginning, you can have them to even pre-process data for the context and then ask the LLM, or plug in an LLM kind of anywhere in the data pipeline where you do a number of different operations to feed like a final application. So what we see right now, in fact, is, for example, for legal documents, you may have streams of unstructured documents. Streams meaning you have versions, right? You have like things that arrive and people edit it, etc., etc. There are like events that are happening on the document. You may have a mass of it, and you want to ask queries. That's almost like what everybody knows now, right? You ask queries to your legal database, and because you need to analyze stuff for your clients and partners, etc. So actually this ability to work with the changing data and making sure that your LLM is answering about the most up-to-date version is pretty crucial. And normally, the kind of the previous version or the contract that was, just canceled or anything should be forgotten kind of from the answer, or the event should be reported to the person who's asking the query. And there are interesting things that you can do as well if you're able to work kind of both with streams and this like changes. So including forgetting and LLMs. You can, for example, set notification or alerting queries. So instead of having a chatbot that you just, you ask, right, what I do is often can explain pathway to a 5-year-old because it's this is what I use it for. It usually helps me in like storytelling. But you may imagine that you set a query of a sort, alert me or notify me when the import regulations of chickens change for my country. And then you don't have to keep on asking. It's not a conversation, right, anymore. It's honestly, you just set an alert or a notification request that's context specific to what you need. And then, it depends on whatever you keep in the context that you feed. So this may be your documents like regulations and PDFs probably coming in, right? And with updating versions, there may be some emails, etc., that you want to process. And you set it once and all the synchronization is taken care of. So these are some of the examples that we see right now, like are pretty exciting with a couple of clients that we see. And they read the intersection of real-time or changing data, events data, and generative AI.
And just to further bring that to life, you do have some pretty big high-profile clients from DB Schenker to La Poste. So can you expand on how they've benefited from your technology? Maybe provide a concrete example about how them, or anybody, in fact, you have to mention any names, of how the ability to unlearn has actually yielded those tangible business results that so many business leaders are looking for.
Absolutely, yeah. So there are many more that I'm not allowed just yet to disclose. But for like in logistics, it's very simple. It's the ability to understand and manage their operations. And La Poste, to give a quote, said that for them it's a paradigm shift. And this learning comes at the very bit, like as I said, it's like don't use a state automaton, just kind of learn it's called the hidden Markov model behind the data, and then you kind of come up with something like a state automaton. So they get it automatically, and all of a sudden they say, it's a paradigm shift because they can manage their operations in a way that wasn't possible before. So it comes with this data fusion and data cleaning and first data cleaning, then data fusion and iterative processing of this. Specifically, La Poste was able to reduce their fleet capex by 16%. So that was pretty nice. It's in the realm of assets management. People use it once you have this structure in logistics or kind of mobility or any location data. You start doing predictions. The most basic one, or maybe sought after one, is ETAs. So for you to know when Santa is arriving, right? But for many people, it's really the decision of, there are some heavy machines that are sorting machines, for example, that take, 20 minutes or like half an hour to start, because this is not an obvious thing. And if you know the ETA of a truck that's coming, or with some containers, with packages, you will know if you can turn it off or on. And then also, knowing when a ship arrives or when a truck arrives, this is like key information just to be able to orchestrate the flows and optimize the operation. So I'd say this is mostly this in logistics. There's of course alerting whenever anything goes wrong. So there are alerts about time, and this it's pretty nice because it's context sensitive. So there are alerts of a sort, like you're waiting longer in that location than usual. It's an intelligent type of alert. Not one just that alerts me when I'm waiting more than 1 hour, but it's like just the fact that there's an issue probably at this step of the process. And then there are also anomaly detection in general that can be on whatever types of parameters. But there are, unfortunately in supply chains we have theft. Yeah. And this is something you may want to detect, but sometimes it's theft, sometimes it's just an extra inspection by the customs. So it's actually good to know if that's the case, and actually learning from the data, you can some of those you can read the noise things, so you get less of such false positives that you would have gotten with just a kind of simple alert rule. And so I'd say this is it for logistics. Then what I was saying, like some big guys working with legal documents. This is pretty core to their operations. The ability to really manage, the quickly changing and structure masses of documents, and having knowledge which is always up to date with potentially unlearning. Funny thing, I think just yesterday I had a client who asked me to specifically highlight unlearning in the offer because he claimed that was the kind of, for him, the key differentiator. So that was pretty cool. Really? So I'd say there are many others, but specifically I'd say unlearning in RAG is key. It's about this like data synchronization, including the downstream systems that depend on outputs of the LLM.
And what I think is really fascinating here is this year there's been so many conversations and debates around what artificial intelligence is learning, and it's all about learning. Where it seems like now we're progressing to AI models beginning to unlearn. And I'm curious, as they do begin to unlearn, are there any ethical safeguards that need to be considered, such as bias mitigation, data privacy? It feels like another Pandora's box right there.
Actually, I think that unlearning is, in some sense, it's a response to the issues of in what LLMs are learning. So you need we already mentioned the right to be forgotten, right?
Yeah.
So if you are to be forgotten, then probably you need to unlearn. And depending on the context, you may not want to wait until the next wave of training the model because it's very expensive. So I'd say in this sense, unlearning helps to implement the safeguards that we want to put on AI in general. Then there are some cases, some things that we see, maybe it's like a bit auxiliary, but there's something that we call catastrophic forgetting in LLMs. It's not so much about unlearning as it is about the fact that sometimes adding new piece of input to the LLM may make it forget some things that were crucial for us. And this may yield unexpected results that are, really not good for us when we want to have, a nice, well-behaved kind of LLM. But then, mostly I'd say that unlearning is rather helpful. It's way more predictable by definition because unlearning has to be a bit more deterministic. And in large language models per se, they're not. You have compression, right? You have the thing I explained, and it's multidimensional, so we can't just have this nice path, let's say, from input to output that we could just take out. Whereas you can do it if you have a tree-like structure.
Catastrophic forgetting. Sounds incredibly dramatic, doesn't it, when you say that out loud?
But it's a term, actually. I think you can Google it.
Yeah.
We'll find it.
So are there any limitations of this unlearning capability and any scenarios where it could actually be problematic or counterproductive? Is anything around that?
Well, if anybody deletes inputs and doesn't want to delete them, then that would be great. Well, the limit is that we still cannot do it for the large language models easily. And we know the problem. I mean, we talked about right to be forgotten, but there's also the big issue around the copyrights, right?
Yeah.
So, but then again, it's the problem of also not having the unlearning rather than having it. I mean, when we unlearn stuff, it's possible that we could lose some of the critical capabilities of the system. And here I'm talking more about the deep learning. But if we don't know how it contributes, right? We're not exactly sure about the extent to which deleting a given point of input will impact, our ability to nicely spread our fingers over the piano board.
And you've had a hugely successful year. You were also, big congratulations, you were awarded the Female Founders Challenge at VivaTech. So I've got to ask, as we look forward to 2024 and beyond, what's next for Pathway? How do you envision the concept of unlearning evolving in the future, both for you, for your company, your clients, and AI in general?
Yeah, so for us, it's pretty much a journey towards real-time learning. And real-time learning is unlearning. So if you want to be able to update the results and work, have a streaming system that works reliably, this is what you need to get. I mean, the current tech, which is Apache Flink, doesn't guarantee something we call consistency. And consistency means that when you get an output, you can actually trust it, an output from the stream. And Flink, you can't. So an anecdote is that you may have folks who would commit fraud or some attacks on payment systems by doing it exactly at the same time, by messing with the time element. Yeah. So for us, it's very much looking at how to manage time in learning, and the fact that we have sequence and data points may arrive late, etc. And here, this is where unlearning kicks in. So we're doing this. What we've done and are working on right now is this alerting functionality. So we actually launched this not that long ago. A couple of weeks ago, we launched the alerting functionality in LLMs. So you can set a notification type of query in your LM applications. And for us, it's very much about enabling data scientists and ML engineers to be able to work with changing or live data very easily. So this includes having, for example, being able to work with real-time data sources and live ML models that we've been just discussing, including Unlearning, directly in their Jupyter notebooks, which is a dramatic change compared to how things have been done so far, where like this ability to work with streaming data or changing data was reserved for data engineers, and us kind of data scientists, ML people, were mostly working on static data because that was the reality. So we want, our goal is really to bring this reactivity, kind of, the fact that, my brain works in real time, your brain works in real time. Why the data science doesn't work in real time? So we want to change this, and making progress here. So Jupyters are new, and we keep on really working in that direction.
Well, it's been a huge honor and privilege for me to geek out with you today. I had a lot of fun, but the fun's not over yet. I always ask my guests, before I let them go, to share with me a song that we can add to our Spotify playlist. It can be a song that means something to you, a guilty pleasure, something that just helps you get your head in the zone when programming, or maybe a power song to walk onto when you're giving a keynote. All I'm going to ask you is, what song would you like to leave us with and why?
I thank you so much for having me. It's been really fun. So my song for today is Shape of My Heart by Sting.
Yeah.
And I will explain you why. Everybody that I met thought that it's a song, like romantic song about love. It's not. It's like 100% not a romantic song. It's a song about probability. And yes, with a certain kind of romanticism about probability, but it's math and probability pretty much. So it's as not about relationships or anything else as it can be. It's really a person who loves probability. And for me, it also rings I have a strange connection in my brain between this and The Color of Magic. If you kind of read books from Discworld, there's a figure of the lady who's the kind of just the main figure to represent randomness. She may or may not help you. You shouldn't pray to her because it wouldn't work anyway. And then, so anyway, The Shape of My Heart. Yeah, that's kind of it. A very strange, surprising song that's not about love at all. It's just about the beauty of the brain and the fact that there is probability. And if you look at this, probability is a pretty recent concept in the human history. We didn't know it.
Wow, you've blown my mind in so many different ways today, from overcoming continuously training AI systems and LLMs with new streaming data, so revisions can be made to certain data points without requiring a full batch data upload, to Sting's Shape of My Heart, and maybe even a Terry Pratchett Discworld reference too. Absolutely perfect for me. Got so much into this episode, but just a big thank you for talking about it in a language that everyone can understand, and understanding that business value that it can offer too. So a big thank you for sharing the breakthrough and enabling AI to unlearn with everyone today.
Thank you so much. It was a great pleasure to be here. Yeah, I had a lot of fun.
So a heartfelt thank you to Zuzanna for sharing her valuable insights and expertise on the transformative concept of unlearning in AI. And I think today's discussion has not only highlighted the technical intricacies, but also the broader impacts and possibilities of this technology across various industries. And I think we learned today that Pathway's approach to AI unlearning is more than just a technological innovation. It's a step forward to a more adaptive, accurate, and privacy-conscious AI system. And this advancement is crucial for businesses and industries that rely on real-time data and decisions, opening the doors for greater efficiency and growth. And for anybody that's interested in listening to tech podcasts, I'd love to introduce you to another one called We Got Your Mac. It's a dynamic podcast brought to you by the tech solutions provider SHI, and they delve into the world of Apple Mac adoption in the enterprise. And the hosts discuss incredible benefits and unique challenges that come with it. So tune into We Got Your Mac on your favourite podcast platform, or simply visit wegotyourmac.com. There's a wealth of episodes and valuable resources over there. Don't miss out on an opportunity to make more informed decisions when embracing the power of the Mac. So a big thank you to everyone listening. If you've got anything you want to share with me, email me, techblogwriter@outlook.com, Twitter, LinkedIn, Instagram, just @NeilCHughes. Together, we can keep questioning, keep learning, and keep pushing the boundaries of what's possible. Hopefully you'll join me again tomorrow. We'll tackle a completely different topic. But thank you for listening as always, and until next time, don't be a stranger.